Piecewise functions are very special examples in terms of continuity. There's a very high chance that these things could be discontinuous at a multitude number of points. More appropriately, it's more than likely going to be discontinuous at the breaking points of all the different types of functions. It doesn't have to be discontinuous, but it just has more of a chance. You also have to be careful with piecewise functions because not only can they be discontinuous at the breaking points, in this case 0, 1, 2, possibly 3 and negative 1, but it could be also continuous in and of itself on the functions we have. Now in this case, none of these functions are discontinuous, and again, these are not discontinuous because that's a quadratic. We know what that one looks like. It doesn't have any breaks or holes. Linear, constant, and again, none of those functions have any breaks or holes in them inherently. Most functions that we would know that have breaks or holes in them, again, are the functions that have original discontinuities. Square roots, rational functions, log functions, tangent, and all of the reciprocal trig functions also all have, again, very specific locations where they might have a vertical asymptote, a hole, or simply just a breaking point and jump. So, in this question it says find f of 2. Well, if we're looking at this problem, f of 2 is not actually here. You'll notice we have equals 2 on the negative 1, which means I can plug negative 1 into this function. I don't have equals at 0 here, so I can't plug in 0. Nor can I plug in 0 to this function because this doesn't have an equal sign. So f of 0 is undefined. F of 1 is defined, there is a value there. But if I go down to here, you'll notice that where x is less than 2, but x is greater than 2, there's no in between, there's no x equals 2. So right here, I would write this as undefined. With that being undefined, I would argue that then f of x is not continuous at x equals 2. So that leads us to the second question. For what value of f of 2 would make f of x continuous at x equals 2? Now, if this thing is a removable discontinuity from the left, which is on this function, and from the right, which is on this function, we would need those two values to go to the same thing. In other words, the limit as x approaches 2 from the left on the function f of x, which is actually equal to the limit as x approaches 2 from the left on this function, negative 2x plus 4. This value has to be equaling the value that I'm going to write over here, the limit as x approaches 2 from the right on the function 0. So this limit is equal to 0. And here, if I plug in 2, I'm going to get back a value of negative 4 plus 4, giving me 0. In which case, the limit from the left and the limit from the right are both equal. If the limit from the left and the limit from the right are both equal, this function will look something along the lines of this. 1, 2, I'm going to have an open circle at 2 going this way up until I get to 3. And again, open circle on 3. And then I'm going to go ahead and have a value from 1 to 2 that's a negative slope. So something that looks like this. But since both of those function values from the left and the right go to the exact same point, this is now just a hole. It's not a jump discontinuity, because a jump discontinuity has to have a break completely in the function. This has a break in the function, but if I fill that hole in, it's no longer broken. It's a smooth curve, even though it does have a corner. So in this particular case, I know that if the limit from the left and the limit from the right are both equal to 0, what value of f of 2 would I have to have? Well, f of 2 would have to be equal to 0. So the question then, for f of 1 to be continuous, f of 1 would have to equal what? So we're going to come back up here and we're going to go ahead and look at this. If I'm looking on x equals 1, you'll notice the function value is 1. Okay. Up here, if I plug in 1, that's again me taking the limit from the left side of 1, I'm getting back a value of 2. If I plug in 1 down here, you'll notice again, if I plug in the value of 1, I'm getting a y value of 2. So from the left and then from the right, again, that's what I actually did. The limit as x approaches 1 from the left on 2x is equal to 2, comma. The limit as x approaches 1 from the right, that's on this negative 2x plus 4 function, that's going to be equal to 2 as well. But if the function f of 1 actually equals to 1 at that location, this is now a jump discontinuity, because the function, the way it behaves, is at the x value of 1, we're going to see a hole here. We're going to see a function coming in here, something like this. But the point of existence that we're looking for is actually here. So again, it's no longer a hole, it's a jump discontinuity, because I have to move here, jump down to here, and then jump back up to get to the top of that function. So this, if I wanted to remove it and make it no longer a jump discontinuity, I would have to remove the definition of that value. So that means that f of 1 has to be no longer equal to 1. And what would I want let f of 1 equal to? I'd have to let f of 1 equal to the value of 2, because that's what the limit value is going to equal to. Again, recall, a function is continuous at a point assuming the limit equals to a number, the function equals to a number, and those two values are equivalent.